Hey, hello there. Today we're looking at Leetcoding challenge question, largest divisible subset. We have a set of distinct positive integers and we want to find the largest subset such that every pair of integers within this subset satisfy this condition. So the condition is that we're doing modulo division between two positive integer numbers. For this to be 0, that means the first integer number has to be larger and it has to be divisible by the second integer. So it's a 4 modulo 2 equal to 0, something like that. The first one has to be larger and it has to be divisible by the second one. And this is a pairwise relationship and it has to be holds for every pair of number in the subset. If there are multiple solutions, multiple subset of the same largest size, we can return either one of those is fine. Looking at an example, we have 1, 2, 3. So every number is divisible by 1, so we can do 1, 2 or 1, 3 obviously. But 3 is not divisible by 2. For that reason, 2 and 3 will never be in the same subset. Otherwise, we have a violation of the pairwise divisible relationship. So so basically we have two subsets of the same size. We can return either one of those. Looking at the second example, we have 1, 2, 4, and 8. We just quickly verify the pairwise relationship, divisible relationship. 8 is divisible by all the number here. 4 is divisible by 1, 2. 2 is divisible by 1. So we quickly checked all the pairwise divisible relationship. They all holds, so it's fine. So let's say that if we look at this, 8 is divisible by 4. 4 is the largest number among all those. That means 4 has to be divisible by 1 and 2. If 8 is divisible by 4, we don't even need to check whether 8 is divisible by 1 and 2. So if the input contains some other numbers along the line after 8, and they are larger than 8, when we decide can we actually expand this subset to be larger by introducing one more number, the only test we need to do is to test whether that new number can be divisible by 8. If that's the case, that new number can be divisible by all the number in the subset. So that tells us we can sort the numbers and try to build this kind of a subset by introducing a larger number one at a time. And the only test that we need to do is to test whether the new number is divisible by the current maximum. So the kind of recursive relationship here, if we represent fi to be the maximum size or the depends on what we want to store here. If this is the definition for fi, we can have this kind of relationship. So basically this is saying that when we want to consider this number as the size, when we want to find out the maximum size of a subset with the i's number as the largest number in that subset, all we need to do is to check all the subset that's with the maximum number that's smaller than nums I, and to see if the nums I is divisible by the largest number in the smaller set. If that's the case, we can introduce nums I to that set and extend that to have that set grow one size larger. We can try to do this for all the subset that's with a number that's smaller than the number we're looking at, and try to grow the subset to be one size larger. So based on this recursive relationship, we can either do top-down search with some kind of memorization, or do bottom-up. To bottom-up, we're basically just populating f0 to fn, n-1, and we want to find the maximum I where this f value is maximized. Once we figure out the maximum, the I for that, if we store the actual subset, we can just read it out. If we always store is sizing information, we'll do one more time to do the backtracking. So it depends on what we store on the FI. Yeah. So If we store the actual subset, it will be more space expensive. It's going to be square time. We have n locations. Every location we need to store the actual subset with potentially n number, so it's n squared in space. But we don't need to do the backtrack. If we only store the sizing information, we will do a backtrack to collect all the numbers that forms that subset. So, but the backtracking is just going to be linear time. So compared to populating this all the fi values, it's nothing, because just look at if we want to populate I5 from 0 to n, that's one loop, for loop, and within the loop, each iteration we consider the numbers from 0 to n minus 1. So it's a square time. Backtrack is linear time, so it's overshadowed by the time needed to populate this, but we can save the space. So let's go up to for that route. So I'm just gonna put it down here, 1D dp with backtrack. So that's pretty much the overall summarization about what we're gonna do. We're gonna sort this so that each time we try to, each time when we consider a number, we try to bring that number into a subset with a smaller number as the current maximum in that subset. Here we're basically using this formula here. Let's just do index. So it align to the formula a little bit better. Do the maximum and plus 1. But we initialize with 0. So that means every single element by itself, every integer by itself is not a subset, because for the subset we need all the pairs. So for that reason, when we add that 1 to that, when we actually form a subset with 2 elements, we're gonna end up with a 1. So that's not the actual size. We're going to increment this by 1 so that this will be the this workout, the mass workout. And we're going to keep track of the maximum index. So the max I, max L is indicating the maximum size of the subset, and also the index for the number that's the maximum in that subset. We're going to use this to do the backtrack. So after this for loop, we basically populated this DP table. Then the only thing left is to collect all the numbers along the way to form this actual subset. Yeah, so basically we're gonna go 8 and look at the left hand side to see a subset with size 3 and ending with some number that's divisible, that 8 can be divisible of. After we find 4, we will try to look towards the left, finding a number that 4 can divisible of, and also that number has to be an end element for a sequence for a subset that's of size 2. So we're going to decrement this size and look towards the left, try to find the first number that the nums at the previous number can be divisible of. So previous number is equal to the number at the max i's location. So this time we do a backward iteration. We are starting with this, so we test the nums at I. And we decrement this, and oh sorry, we put this new number as the previous largest number, and also decrement this the length. I guess to avoid confusing, just rename it. I need to hurry. Yeah, I think this should be the code. Does it work? It's 2-1, not 1-2. Yeah, actually, I don't need to store this. All I need to do is to check the maximum, right? Yeah, I can get rid of that. It's working. Let me try this. Looks fine. Let me add one more term. This time it will be 3 multiplied by this 81. Does it work? Yeah, it's picking up. Okay, let's see. What about empty case? Did I handle empty case? Nope. Yeah, so let's handle that. Okay, it looks fine. Yeah. So that's pretty much the code. Do a sort. So because that when we try to consider about those subset, it's easy to think about it when we try to add one more larger number to expand the subset. Because all we need to do is check the current maximum with the new number we try to add. So process the number in a sorted order. It's a really nice. Here is the double loop, to build up this DP array, one-dimensional DP. And once we figure out the maximum, we just do one pass backward towards the left to collect all the numbers to form that actual subset. Alright, so that's, did I submit? Yeah, submit it. That's the question today.